Whenever a new technology is introduced, the engineers that are being asked to use it are naturally curious not only about the benefits, but also about the reliability and the robustness and the fitness for purpose in the real world. So let's talk a little bit about that. Reliability and robustness. Okay. Reliability is defined as the propensity of the device to survive over time under normal operating circumstances, the specified temperature ranges, specified voltages, and currents, safe operating area, these kinds of things. And what we have done with our GaN technology is we've qualified it according to the JEDEC rules as those rules have been modified and guidelines have been modified for gallium nitride. And we have 100% reliability on against these tests. So from a point of view of long-term reliability, our products have been tested, they've been stressed, and they are as reliable or more reliable than any silicon-based technology. Now let's consider robustness of the gallium nitride transistors. This is what happens when you overheat them, what happens when you over-temperature them or overstress them electrically. Now, we specify our GaN, the POWI GaN, is specified to 650 volts. But that's specified, and that's perfectly adequate for a flyback power supply. But it may not be adequate in a situation where there is a spike or a surge or something has happened on the input to the power supply that creates an overvoltage event. And so we further specify our gallium nitride with a 750 volt for a non-repetitive, non-repeat condition. So what this means is you can use 750 volts as the derating in your power supply. Another way to look at this is if I draw a graph of a drain waveform of a power supply, of a flyback power supply. This is the maximum voltage stress point, and you should design your power supply so that this is normally 650 volts or less than 650 volts. If, however, a surge comes in or some unexpected event comes in, it's permissible for this to go up to 750 volts. And you may ask, well, what is the consequence of going up to 750 volts? We've done tests where we run the power supply and measure RDS on of the GaN transistor. And while we're using 650 volts, the RDS on remains at its nominal level. And then we hit it with a period of high voltage. For this period, that could be millions of hits. So this is millions. And this is time. Millions of hits. And what we see is that RDS on raises up, and then when you stop hitting it, RDS on comes back down again to the original level. And this effect is around about 1% increase in RDS on. So by exercising this level, you're not risking the function operation. You're not going to blow your power supply up. What you're going to see is a slight increase in the RDS on. Unmeasurable under most circumstances. So how do you think about this 750 volt non-repetitive stress point? You have to understand that GaN does not avalanche. So the actual physical breakdown of the material is far, far higher than 750 volts. This number has been chosen as a means of defining how the product's going to stay within the datasheet spec. If you are using a silicon transistor, this would be a point at which you would not want to exceed because you may avalanche the part. Repetitive avalanche causes thermal damage to a part, and the part will eventually break. But because GaN has a gentle approach to failure, the failure happens at much higher voltages, and so it's perfectly safe to operate your Power Integrations gallium nitride part up to 750 volts. To learn more about Power Integrations' exciting new gallium nitride products, go to power.com.